Assalamualaikum and hi everyone, my name is Nur Alabakis Binti Roslan and I am here to present my final year project titled Characterization of Biofilm Forming Capabilities and the Potential of Tetrahydrobetacarboline Against Pseudomonas aeruginosa Clinical Isolates. So let's begin. For the introduction, antibiotics have been used for over 70 years to treat the bacterial infection with diverse medical applications. However, their misuse has led to a rapid increase in antimicrobial resistance known as AMR. AMR is a major public health issue as some bacteria have become resistant to many kinds of antibiotics. In this case, Pseudomonas aeruginosa is a significant bacterium known for its antimicrobial resistance worldwide. This bacterium continuously evolves resistant to the antibiotics such as aminoglycosides, quinolones that are used to treat its infections. Tetrahydrobetacarboline, that is known as THBC, has been shown to possess a number of pharmacological properties include the antiviral, anti-leishmania, antifungal, anti-cancer, antithrombotic, and anti-malaria. Therefore, THBC has shown potential as an antibacterial agent with moderate to good activity against the various bacteria. The objective of this study has been divided into three. Firstly, to characterize the biofilm forming capabilities of Pseudomonas aeruginosa from clinical isolates using the biofilm formation assay. Then, to measure the antimicrobial susceptibility of Pseudomonas aeruginosa against THBCs using the diffusion assay. And the last one is to compare the protein profiles of the Pseudomonas aeruginosa in clinical isolate using the glycoprotein staining technique. AMR occurs when the bacteria, viruses, fungi, and parasites develop the ability to resist to the effects of medications that were once effective against them. This resistance results in infections that cause severe illness and frequent treatment failures. For example, in Pseudomonas aeruginosa is an incredibly adaptable pathogen capable of surviving in various environments and forming biofilm, making it a common cause of infections, especially in individuals with weakened immune systems. In chronic infections, the formation of biofilms is critical to Pseudomonas aeruginosa's ability to cause the disease and resist to antibiotics. THBC is a beta-carboline indo-alkaloid is known for its diverse biological activities, including antimicrobial properties. Moreover, the protein profile can impact the antimicrobial resistance in Pseudomonas aeruginosa, highlighting the intricate nature of bacterial modification and resistance. This study used various methods to achieve its objective. Firstly, the stock culture of Pseudomonas aeruginosa were maintained to ensure a reliable bacterial source. Then, biofilm formation assay was conducted by adding 200 microliters of Pseudomonas aeruginosa in LB broth into the wells and incubate for 24 hours. Then, MBIC was conducted by adding 100 microliters of Pseudomonas aeruginosa culture, incubate at 37 degrees Celsius, followed by adding the 50 microliters of the THBC compound solution and 50 microliters of CAMHB and incubate for overnight. The next day, 5 microliters of resazurin dye was added and incubate for 1 hour to monitor the color changes. Then, this diffusion assay involved the spreading of bacterial suspension on MHA plates and placing antibiotic discs. Next, protein extraction, including the outer membrane proteins, was performed and protein concentrations was measured using the nanodot spectrophotometer. Samples then were loaded onto the SDS page to separate proteins by the molecular weight and stained with the procyo-emerald glycoprotein and cyproruby protein testing to detect the glycoprotein and total protein respectively. Let's move to the results and discussion. The biofilm formation assay results Pseudomonas aeruginosa clinical isolate exhibit varied biofilm forming capabilities. It demonstrates that the positive control strain confirming its strong biofilm forming capability. The negative control strain indicating minimal biofilm formation. Comparing these controls, strains P6 and P7 were classified as moderate biofilm producers, forming dense biofilm that hinder immune response and antibiotic effectiveness, while strains P8, P9, and P10 were classified as weak biofilm producers, potentially making infections more treatable. In the diffusion assay, we evaluate the efficiency of the THBCs diluted in the DMSO are more effective than those diluted in the DH2O at inhibiting the Pseudomonas aeruginosa. In this case, both isolates and control were tested to confirm its efficiency. Firstly, all isolates were susceptible to colistin, while compounds G5A, G5B, and G12A show resistance to the Pseudomonas aeruginosa isolates. However, in Pseudomonas aeruginosa control, it shows susceptibility to the colistin and G5A. The diameter for the colistin and G5A were 2.2 cm and 1 cm. However, its effectiveness was lower compared to the colistin, suggesting that G5A is less potent but still promising. These compounds were dissolved in the H2O instead of the MSO, which could have affect their solubility and consequently their effectiveness. Despite strong binding affinities, factors like acid conditions and bacterial resistance mechanism may influence their efficacy. From the MBIC, THBCs inhibit biofilm formation of Pseudomonas aeruginosa. Compounds were tested at 5 mg per ml, inhibit the bacterial metabolism and biofilm formation indicated by no color change in the resazurin assay. G5A shows strong inhibition likely due to the high affinity for bacterial targets and effective cell wall penetration. Compounds G5B and G12A, despite no activity in this diffusion assay, inhibit biofilm formation, suggesting specific actions against biofilm-related processes. THBC compounds disrupt the bacterial cell membranes, making them more permeable and leading to the cell death. They also prevent initial bacterial attachment to surface and interfere with the quorum sensing signals crucial for the biofilm development. Based on the MIC, the results turn out that MIC values of the THBCs against Pseudomonas aeruginosa are less than 20 microgram per ml. THBC compound prevent color change in the resazurin assay, indicating strong antimicrobial activity by inhibiting bacterial metabolic activity. Specifically, compound G5A, G5B, and G12A show potent antimicrobial properties that effectively hinder bacterial growth. All tested concentrations successfully inhibit bacterial metabolism, suggesting optimal effectiveness. These findings suggest that these compounds could be valuable for treating infections caused by the Pseudomonas aeruginosa, potentially overcoming bacterial resistance mechanism. The Cypro-Ruby protein gel chain analysis provide a detailed examination of total protein content in various Pseudomonas aeruginosa strains. The first band in P6, P7, P8, P9, and P10 shows similar medium molecular weight bands which range from 180 kilodalton to 193 kilodalton. Therefore, they are likely corresponding to the LPS binding proteins and flagellin-associated proteins. Then, bands in the low molecular weight range around 25 to 46 kilodalton are likely to include proteins such as OPRF and PIL-A according to the UniProt. Glycoprotein profiles correlate with the biofilm formation capabilities. Findings include that strains P6 and P7 show prominent and reveal high-intensity bands since they were classified as moderate biofilm producers. The multiple high-intensity bands in P7 imply a complex glycoprotein composition like arginine and PSL proteins that support a strong biofilm structure. In contrast, a weak biofilm producer show lower intensity of the glycoprotein, indicating fewer structural components for biofilm stability. However, the presence of low glycoproteins such as LAC-B and type 4 polyproteins indicates an attempt to form a biofilm, albeit less effectively. These patterns contribute to enhanced virulence through the biofilm formation and resistance mechanisms. So these are the reference. So that's all from me. Thank you.